Hello everyone. Today I am going to present a project titled Machine Learning Based Industrial Machine Failure Prediction. In modern industries, machines operate continuously and generate a huge amount of operational data such as temperature, vibration, pressure, and rotation speed. Our project focuses on predicting machine failures in advance using machine learning techniques so that industries can perform maintenance before breakdown occurs. Problem statement. Traditional maintenance methods are mostly reactive or scheduled at fixed intervals. These approaches often fail to detect faults at an early stage. As a result, industries face unplanned machine downtime, increased maintenance expenses, reduced equipment lifespan, loss of productivity. Therefore, there is a need for intelligent system that can analyze machine data and predict failure before they happen. Our project addresses this challenge through machine learning and a web-based prediction platform. Abstract and project overview. The main objective of a project is to develop a predictive maintenance system using machine learning algorithm. The workflow concludes data collection, data visualization, model training, and deployment using Django. The trained model analyzes machine parameters and predict whether a machine is likely to fail or continue operating normally. The final system provides an easy to use interface for monitoring machine health and making proactive maintenance decisions. Literature review. We studied several research papers related to predictive maintenance. The first paper proposed a machine learning model that predict failures up to 5 days in advance and optimize maintenance scheduling. The second paper focused on predictive maintenance for water pump using IoT device and the random forest algorithm for real-time fault detection. Another study was on various AI and machine learning techniques used in industrial equipment failure prediction and identified LSTM as one of the commonly used approaches. These studies demonstrated that machine learning significantly improves maintenance planning and reduced downtime, which motivate us to develop our own predictive maintenance system. Issues and challenges. Although machine learning offers powerful prediction capability, there are some challenges. High computational requirement, dependence on high quality dataset, need for predictive retraining, difficulty in interpreting learned features, increased complexity when dealing with multiple data sources. These challenges must be carefully addressed to ensure reliable prediction. Proposed working. Our proposed workings analysis mentioned parameters such as temperature and vibration to identify early sign of failure. The historical data is used to train machine learning classification models. Once trained, the model predict whether the machine is a healthy condition or likely to fail. The prediction system is integrated into a Django based web application where users can view prediction results, monitor machine health, and enter machine data. This helps industries implement condition based maintenance and avoid unexpected breakdowns. Architecture diagram. Requirements. List of modules: data preprocessing, data analysis of visualization, implementing random forest classifier, implementing gradient boosting, implementing naive Bayes, and deployment. Data preprocessing: data cleaning, handling missing values, removing duplicates, and preparing data for training will be handled here. Data visualization: using graphs and charts to understand patterns, trends, and relationship within the dataset. Machine learning algorithm: we implemented random forest classifier, gradient boosting, and complement naive Bayes. In gradient boosting builds multiple weak models
You.
sequentially. Even each new model focuses on correcting the error made by previous models, resulting in improved prediction performance. Random forest classifier. Random forest classifier is an ensemble learning algorithm that combines multiple decision trees. It improves prediction accuracy by taking the majority vote from several trees and is highly effective for classification problems. Complement naive Bayes. Complement naive Bayes is an improved version of the naive Bayes algorithm. It performs well on imbalanced datasets and provides fast and efficient classification, making it suitable for predictive applications. Deployment. After training the model, the best performing model is saved as a pickle file and integrated into a Django framework. The deployed web application allows user to enter machine parameter and instantly receive predictive results. The implementation screenshot shown in the presentation demonstrates the user and the predictive output of the system.
So after we managed to run the manage.py, which is like the deployment for the project. We use this web page to predict the mission failures. So this web page is like moreover app like structure where the user or the industries could use this uh, application in order to predict their mission's failure or the consistency of the mission. So while we come to the landing page, we get to log in or either register. So I go to the login over here. Then we get to the home page. After getting to the home page, we get like the profile part of the view where you can view your profile, and also we have a database. This acts like the previous datas or the values that has been given by the user for their prediction analysis. So you can also refer to this datas for moreover like a history of datas where your machine gets to the faulty analysis, and this is like the prediction phase. So you have to get the cumulative view of your uh, data machine's data. So after getting the average value for every temperatures like air temperature, process temperature, rotational speeds and all, and you can find out the either there is error or no error. So I am going to give a data for prediction of some sort of an error. So I'll just give once. So when I give this and we get to the prediction page where the data I have given is for power failure. So at the rate of some over here, the description, like literally it just says that, what is the current condition for this power failure cause, uh, the symptoms that the device could be showing, and the precautions to prevent this from power failuring, and the preventions. Like you get to know the cause. The description literally says how and exactly what is the cause for this. Symptoms is like the similarities that the machine could show in sense to find the power failure, and then we go with the precaution stage and the prevention stage. So this is like the overall applications we have built, and you can see like this currently the database gets to store the value and you can predict it afterwards. So this is like the overall application we have built. This can be used for like the real-time analysis of a machine failure. uh, this is currently being made for a local host part. We can deploy it for the worldwide use when it's like moreover refined. Thank you.